Hey everyone, welcome to day 6 of Math 133. Today we are going to be covering the Chapter 3 review. Part of the Chapter 3 review, we also have a Google Sheet project. We're going to be doing both of those today. So make sure you work on the 1.2 lecture notes and 4.1 lecture notes. If you've done all of Chapter 1 lecture notes, don't forget to submit them. By the way, you are welcome to work ahead in this class. It's very easy to fall behind. Once you fall behind, things are late, you lose points. It's difficult to complete assignments because you get confused because, you haven't seen that material before. So, you are welcome to work ahead to avoid that. So, if you want to look at day 7 or day 8 and look at what the lecture notes are there, you're welcome to submit those. Okay. You don't have to wait until I tell you, hey, go look at these lecture notes. Okay. Um, okay, so today is the start of week 4. So if you are on the Zoom call, then you do not need to go to the discussion board and fill out week 4. But if you are listening to this on the recording, you can't come to class on Tuesday or Thursday. You're going to need to make sure you go to the discussion board and fill out the topic there for week number 4. Okay. I'm here in Canvas, and so if you click on Chapter 3 Review Worksheet, there is a link that's going to take you to the data sets for all of our worksheets. If you click on that, it'll bring you to this guy. And we've seen this before, but if you scroll down to the worksheet that we are working on today is the Chapter 3 Review Worksheet. There's a link for Google Sheets as well as a link for StatCrunch. So if you click on those, oh, well, that didn't work. Hmm. We'll try that again.
I think you just need to log in, Joe.
Ah, okay. Yeah. So we'll go to statcrunch.com and log in. That's fine. So signed in, sign out. Okay, so in the upper right corner, we'll sign in. There we go. All right, so for the chapter 3 review worksheet, we'll click on the Google Sheet, and that's going to bring us here. This is our project for today. And then if you click on the StatCrunch one, hopefully now I'm signed in. There we go. That's what I wanted. So this basically has some of the numbers we're going to be using today. I could have just typed them in, okay, but I don't want to have to type all of that in. That's going to take forever. So yeah. So uh, by clicking on that link for the Chapter 3 review StatCrunch, I've got all that data. Okay. So once again, you'll go to the link or you'll click on Chapter 3 review worksheet in Canvas, click on the where it says this link, scroll down to the Chapter 3 review worksheet and click on the two links that are there. Okay. All right. But we're not going to start there. We're going to start on the Chapter 3 review worksheet, which is in your course pack, and that's on page 339. Okay, so go get your course pack, and you're going to pull out the Chapter 3 review worksheet. There are 4 pages to it. So we're going to work on this today together. So you'll want to go get that. Okay. So at the start, I'm going to give you some hints on some of the problems that are probably a little more difficult, and then we'll come back through and we will work on it together. Okay. So to start with, the following frequency distribution shows the number of athletes for all participating countries in the 2024 Summer Olympics. Okay. So, um, this is a frequency distribution. This is saying there were two countries that sent somewhere between 500 and 600 uh, athletes to the Olympics. Okay, so those must have been big countries. Okay. Um, most countries, there were 173 countries that sent somewhere between 0 and 99. Okay. So we're going to fill in these columns, and those columns actually are our project for the day. Okay. So going back over here, when you click on the Google Sheet, it brings you to this spreadsheet, and these are the exact numbers from the spreadsheet. Okay. So what we'll do is we will fill these in, okay, and then we'll submit the project, and then we will write our numbers on paper as well, okay? For the project, you're going to start by hitting File, Make a Copy, and we'll rename this. Okay. And make sure you save it in a good spot. So you can do My Drive, or if you have a place that you are saving your projects, you can put it there. Okay. And now we can actually edit this. Okay. So, uh, and again, slow me down, or ask questions if there's ever any point where you're like, I'm not sure where we are. How did you get to that? How did you do that? Okay. So we need to start with filling in our midpoints. Okay. So each of these groups, 0 to 99, each of these classes, bins, whatever you want to call them, uh, there are a certain number of athletes, and we need the middle number. So if I was to count from 0 to 99, what's the middle number? Okay. So uh, we're going to start by doing one of these midpoints, and that's going to be our foundational midpoint. Okay. Uh, does anybody remember how we uh, get a foundational midpoint? What's the formula for a foundational midpoint?
We add the uh, lowest point from one to the lowest of the next and divide by two.
That's right. So what we'll do is we'll take the average of the two numbers um, for the lower limits. So yep, you got it. So let me jump over here. So our foundational midpoint is going to be, you take the lower limit of the class that you're on, the first class, and then you look at the next class and you take the lower limit there. So the next lower limit, and you're going to divide those. You're going to add them up and divide by 2. We divide by 2 because we're just averaging. Okay. All right. So for this one, we'll do equals, open our parenthesis. Our lower limit here for this class, 0 to 99, the lowest number is 0. And then we do plus. And then the next lower limit, so not 99, that's the upper limit. I got to go to the next class down, which is 199, and I take the lower limit there, which is 100, close my parentheses, and divide by 2. Okay. So the midpoint here is 50. Okay. Now, by the way, I did this class as my foundational midpoint. I didn't have to. I could have started with this one. If I didn't have a lower limit here, like if this had said 99 or less, um, I guess I could, make a guess that 0 is my lower limit, but that can break things. So if you don't have a lower limit on the first class, just go to the second class. That'll be your foundational midpoint, and you can just subtract the width instead of adding it. Okay. Um, anyway, so for this one, I have 50. Okay. And then I don't need to use the same formula over and over. Because there's 5 more classes. I don't want to have to type all that out. And in fact, if I had even more buckets, more rows, more bins. I don't want to have to do that over and over. So I want a formula that I can just copy and paste. Okay. So what I'll do is I will take my foundational midpoint and I'll add the width. Okay. The width of these classes. Okay. So let's figure out what our width is. Okay. So the width is it's very similar to the foundational midpoint. You look at the lower limits of the two different classes, but instead of adding them, you're going to subtract. Okay. So what that would look like for the width is you take the uh, the lower limit and the lower limit and you subtract them. Now we'll start with the next one because it's always going to be a little higher. You don't want negatives, right? But we'll subtract the current lower limit. Okay. So it's the same numbers, okay? We did 0 plus 100 divided by 2. It's the same numbers. It's 100 minus 0 for our case, okay? So the next lower limit from where we're at is 100 minus, and then the current lower limit was, for 0 to 99, was 0. So equals 100 minus 0, which of course is 100. So, okay, so now that I have that, I can calculate all the other midpoints. Right? So what I'll do for that is I take the previous midpoint, okay? And in this case, I don't want the number. I want the actual cell reference, okay? So it'll be, B2 or B8 or whatever, but you're going to add the width, okay? So what does that look like? So what you'll do in this cell right here, you do equals, and you'll click on the previous midpoint, which in this case was 50. You'll notice it doesn't show up as 50, it shows up as B2. Okay, that's the cell reference. Basically, you're telling Google Sheets or Excel, go to that cell, go to cell B2, grab whatever number's there, and then you're going to add the class width, which in this case is 100. Okay. And there it is. Okay. So now that I've got that, I'm going to copy that formula for all these other cells. And there we go. Okay. Or you can hover over, or you can click on the cell here and you can hover over the little blue dot in the lower right hand corner and click and drag that formula down. Either way is fine. Okay. And now we have our midpoints, okay? And we're going to need those midpoints in order to be able to calculate our mean and standard deviation on the Chapter 3 review, okay? So that's why we're calculating those, okay? So, okay, next is the relative frequency, okay? So for relative frequency, you click on the frequencies. And again, this is going to be the cell value, okay? And you're going to divide by the total, okay? So the total, so I need to find the total. I don't have a total yet, okay? So let's do that next. So to do the total, we'll do equals sum parenthesis. And in this case, Google Sheets is making a guess. The AI is saying, hey, do you want to sum all of these numbers? Yes, that is correct. Good job at guessing on that. So you can hit tab, okay? If it was wrong, you would just, or if you're in Excel, you just highlight these and drag it down until you get cell C2 through C7, close your parenthesis, and there's our total. So there are 207 countries that participated in the Olympics. So that's our total. But to do our relative frequency, we're going to take our frequencies and divide by that total, okay? So let's go to cell D2 and we'll hit equals. And we're going to click on, so Google is guessing, do you want to take this number and divide by this number? You're very close, Google, but not quite right. So I'm going to reject your suggestion. Sorry. But I'm going to do equals, and I'm going to click on the 173 because that's the frequency, and I'm going to divide by 207. Okay. Again, it's guessing. Do you want to do that for everything? Almost. I don't want this one down here. So no, not quite, Google. I just want these ones filled in. Okay. Now, we only want 3 digits after the decimal. So up here where it says .0 with an arrow, we're going to click on that and keep clicking on it until we have 3 digits after the decimal place. Okay. Now, by the way, you didn't have to type 207. Okay. If you wanted to use cell C8, which was, Google's suggestion, you can do it. It's just going to be a little more tricky, okay? You can't type C8 as Google suggested because when you drag that formula down, you're going to get errors. When you copy a formula, what's going to happen is Google is smart enough to know, okay, you want me to shift the cell reference every time. Well, I do for the numerator, but for the denominator, I don't want you to go to the next one down. I don't want you to go to cell C9 because there's nothing there. I want you to keep looking at cell C8. So what you can do is you can type, as Google is suggesting here, equals C2 $C $8. Okay. So it looks like this. What the dollar signs do is it says, okay, when you copy this formula, always keep looking at cell C8. Okay. Because for like this one right here, when I copied the formula down, it's saying you want me to go to cell C4, which is this one, the 3, divided by the total, which is still C8. Okay. So $C, $8. And you don't need both the dollar signs. Technically, you only need the dollar sign in front of the 8 if you want to be super fancy. Um, but for our purposes, we could have just typed divided by 207. Okay. Really, the dollar sign and stuff, that's only if you are like uh, if this was a report that I was building for, my leader or for my CEO, and I show this to them, and they're like, "Oh, this is a great report. I want to see this every week, or I want you to have this report available for me once a month." Well, I don't want to have to change this formula every month because my total is going to be different every month. Okay. Um, and so I don't want to have to go in and change all these denominators. So if that's the case, I would use the cell reference with the dollar signs around it. Okay. If I was trying to automate this report. So anyway, for our cases, don't worry about it. Next is cumulative frequency. And cumulative frequency has 2 steps to it. Okay. I'm not going to put equals here. I'm going to put the steps. So first, copy the first frequency. Okay. It's the same number. Okay. Step 2, then we'll do a formula. We'll do equals, and you're going to click on the previous cumulative frequency. Okay. Plus uh, whatever that row's frequency is. So what does that look like? So first step, we're going to copy the first frequency. Okay. So right here, 173. I'm just going to copy that over here, 173. Okay. For the next cell down, we're going to do equals, and we're going to click on the previous cumulative frequency, and then we're going to click on the frequency for that row. Okay. So what that looks like is equals. I'm going to click on the previous cumulative frequency, which is the one right above it, which is this one right here, cell E2. Plus, then I'm going to click on the frequency in the row that I'm on, this row, row 3, and that's this number right here, 20. So my formula is E2 plus C3. And that's the formula I can copy down for everything. Nope, sorry, that is not correct, Google. It should look like this. Okay, the last number should be 207. Last number should match your total, and the first number should match your first frequency. So these two numbers should be the same. Okay, and these two numbers should be the same. You don't need to highlight them. I'm just pointing out that if you did it right, these two numbers are the same. Okay. That was cumulative frequency. Okay. The last one is cumulative relative frequency. And there's two different ways you can do this one. Cumulative relative frequency. Okay. Um, so I'm gonna do it I'm just gonna do it one way tonight. I did it this morning and I messed it up. So uh it was an easy fix, but I'm gonna make sure I don't mess it up this time. So um with relative frequency, you take your you take the cell value, the cell reference of the frequencies and divide by the total. So it's gonna be the same thing, except you are going to click on the cumulative frequencies. Okay. You click on the cell value there and you divide by the total. Okay. So you click on the cumulative frequency and then you divide by the total. So let's do that. Okay. Equals. I'm going to click on the cumulative frequency, which is this one, 173, divided by the total, which is 207. Okay. Or you could do $C, $8, either way. Okay. And then we'll copy that formula for all of these. Okay. And we'll make sure we only have 3 digits after the decimal. Okay. All right. So the formula I typed was E2 divided by 207 equals E2 divided by 207. And you'll notice that these numbers are the same. So we'll do green this time. So if you did it right, these two numbers should also be the same. Okay. And then this one should always be 100%. All right. There's one last part to the project, and that is we need to do a graph. So I'm going to go back over the frequencies right here. So column C, I'm going to highlight those. I'm going to click and I'm going to drag down. Don't include the 207, okay? Don't include the total. So I just highlighted these rows, and then I go to Insert Chart, and here's this. Okay. Move it out of the way. And that's it. That's our project for the day. Okay. So we need to share this. We need to submit it. So in the upper right, you're going to click on Share, change the access from restricted, change it to anyone with a link. And then you're going to click on Copy Link, and it'll say Link Copied. And now we're going to go back over to Canvas. Okay. So let's go back to Canvas, and we're going to click on our project, and we're going to submit it. So where is it? Here it is. So the Chapter 3 review Google Sheet project, if you click on that, there's a couple links there. There's a link with instructions. There's also a video here. There's also a Google Sheet link that's going to take you to this one. I don't need any of that. I just need to scroll to the bottom where it says web URL because I've copied it. And I'm going to paste it here. And then submit assignment, and I get my confetti. Yeah, all right. Jonathan, you have your hand up. What's your question?
Which one do you highlight to make the graph?
Sure. So back over here in my project, I'm gonna click on cell C2 and I'm gonna drag it down to cell C7. Okay, so I'll get rid of all my colors. I don't need all these colors. It's these ones. Okay, so notice I'm not grabbing the 207. If you grab the 207, you'll get some kind of crazy bar at the end. It's not bad with this one, but I want my chart to look like this. Okay, and then you hit insert chart. Okay,
Certain chart.
insert chart.
Alrighty, thank you.
Yeah, no problem. So, and then share, and then don't forget to change this from restricted, change it to anyone with the link, please. All right, so now that we've submitted that, that was the first part of today. So we did our Google Sheet project. Next, we're going to look at the review worksheet. Okay. So in our course pack, page 339, okay, we're going to need to fill in all of these numbers here. Okay. So I know it's kind of annoying to have to fill all of that in, but it is worth points. So it's worth 4 points. So make sure you fill in all those numbers. I'm sure you can do that on your own. Let's actually move on, at least for now. And I'm going to give you some hints on some of the ones that are a little more complicated. So that way, when you're studying this, you go back and you're getting ready for the final, you can look and see how we did those, and you can see where the explanations are. But it's also, I'm going to give you some hints and then I'm going to stop the recording. So those of you working on Zoom can use those hints to finish the ones that I think are a little more difficult. But once I stop the recording, we'll go back through and we will finish the project or finish as much of the worksheet as we can today. Okay. All right. So, um, question C, describe the shape of the distribution. Is it skewed left, skewed right, or symmetric? I think I gave you the wrong page last time. It's page 96. There's a table that explains how to do that based on whether you have a chart or have, box plots, or if you just have uh, the mean and the median. Okay. Um, Number of athletes is quantitative, discrete, or continuous. That you'll find on page 9. Um, by the way, what does discrete mean again? Can you remind me what is discrete?
Means that it's not a decimal.
Yeah. So for this class, that's how we're going to define it. We're going to say that it has to be whole numbers. When you're counting, it's 1, 2, 3. And so, um, technically in math, there's a different definition for discrete that does allow you to use decimals, but we're not going to worry about that. Okay. Okay, great. So, next, so is the value a parameter or a statistic? That depends on whether you are looking at a population or whether you are looking at a sample. Okay. All right, this is the one I wanted to talk to you about. Part I. Find the mean and the unadjusted standard deviation. Okay. So part I down here, find the mean and the unadjusted standard deviation. So to find a mean, you take your numbers and you add them up, and then you divide by how many numbers there are. Okay. That's not too bad, right? That's how we calculate an average. But for standard deviation, we are going to compute standard deviations in this class, and there is a formula for it, but we are not going to use that formula. Okay, so there is a page where you can go and you can look at the formula if you want. You basically take each number and you subtract from the mean, and then you square it, so there's no negatives, and then you add them up and divide by how many numbers there are, and then you square root that. So I said a second ago, it's you add them up and divide by how many numbers there are, which sounds like an average, sounds like a mean. And that's standard deviation is very closely related to mean. Okay. You can kind of think of it as the average distance away from the mean. Okay. Standard deviation is a measure of how spread out your data is. If your numbers are very close together, okay, that means you'll be able to make more accurate predictions. Okay. So like if I was trying to figure out, uh, how tall my son is going to grow up to be, I can look at the average height of either people in my family or the average height of people in the US. Um, and that's going to give me a number where I expect him to be, but is he guaranteed to be that number? No. He might be taller, he might be shorter. How much taller or shorter? That's asking how spread out our data is. And so that's what standard deviation does, is it allows you to tell um, whether your data is clustered together or whether it's very spread out and then your actions will be wildly different. Okay. Um, anyway, that all said, we are going to calculate standard deviation, and there's three methods that we're going to use, and they're all on page 254 in your course pack. And for this particular one, we're going to be using method 2. Okay. In your course pack, there is a section on page 253. Yours is going to be yellow. I didn't get a fancy yellow one. Mine's just boring and white, but this is your exam notes packet. Okay. And it says do not write on this packet. You can write on this. Okay. So I wrote you got this for when I take the exam. Okay. So give myself a little pep talk. You can write on your exam notes packet. I think Cindy and Elaine had you write the formula for fences on there already. So um, if not, you can also have an 8.5 by 11 piece of paper with whatever you want on it, and that can also be a place that you put in, formulas that you're going to need. Okay, but that's page 253. Page 254 is where there's three methods for calculating means and standard deviations. Okay, the first one is if you have raw data. Raw data is where you just have a column of numbers. Just here's the numbers I have. And that's what you're usually going to have in the real world in an actual like job situation. But you might have a frequency distribution. And that's what we're looking at here for this one. We have our classes, our bins, our groups, however you want to define it, and we have our frequencies. Okay. So for a frequency distribution, we'll use method 2. And the last one is if you have a probability distribution, which technically this is actually a weighted average, and weighted averages are very useful. We do that all the time. Your grade in any class that you take is a weighted average. Okay, so it doesn't necessarily have to apply to a probability distribution. Probability distribution is just a special case of weighted averages. Regardless, we won't be talking about method 3 until we get to probability in chapter 6. So but yeah, so there's that. Okay, so page 340 now. Let's go to that. And on page 340, we have a column of data. The following shows the per capita energy usage for a random sample of countries in the world. Okay, so this time we have a sample. Okay, so that's going to change whether we are looking at mu or x bar. I mean, that doesn't really matter. Um, but the first thing we're going to do is we're going to calculate a whole bunch of things. We're going to calculate the mean, which is x bar. We're going to calculate n. We're going to calculate s, which is the standard deviation. Okay. Um, so we said a second ago that we have three methods for calculating standard deviation. So this is going to be page 254, method number 1. Because this is a single column of data, it is our raw data. Okay. So we would go to, in StatCrunch, we would go to stat, summary stats, columns. Okay. And we've done that before. So, by the way, oops, let me get back to StatCrunch where I was. StatCrunch is being mad at me today. Okay. So a little while ago, I had you click on the link in Canvas that took you to this sheet, and then for the Chapter 3 review worksheet, you click on this for StatCrunch and then sign in, and it has the data here. It actually has energy usage, already has the exact numbers from the review worksheet, so you don't have to type them all in. Okay, so we would do stats, summary stats, and columns, and then we'd be able to calculate uh, all of these things, okay? Not just the mean and the standard deviation, but all these other ones as well, okay? All right, so next, we said that uh, we do all that. For this one, interpret. When you see the word interpret, we mean we want an English sentence, okay? So Q2 is some number. You're going to calculate what that number is. Let's say the number's 10. 10 what? 10 units. Okay, well, what does that tell me? Okay, so, as mathematicians, our job is to be able to translate math, the language of math, into English. Okay, and that's what I do as a data analyst. So I don't just build a bunch of reports and calculate the numbers, and here's the number. If I do that, that's that's not analyzing the data. I'm not doing my job. My job is to be able to take that data and understand what it means. Okay, you can have AI calculate all of these, numbers whenever but that's not going to help you if you can't understand what those numbers are telling you. Okay. So what you need is you need someone who's able to say, okay, because of this number, we should hire more people, or maybe we should stop advertising in this medium, or maybe we need to, change something about our business. And those business decisions are going to be based on the data that we have, and it's going to be based not just on that, but also we have to be able to interpret it and understand it. Okay, so. Next one, same thing. I want you to interpret means we're going to be writing a sentence, okay? And the sentence you'll write for this one is actually on page 253 at the top. There's a script for interpreting the mean and the standard deviation. We expect the x value to be mean. Don't forget to include units. Give or take standard deviation with units. Okay, so it's the give or take script. Okay. All right. Lower fence. There's a formula for that. There's also a formula for the upper fence. The formula for lower fence is Q1 minus 1.5 times the IQR. Okay. So question for you guys, what is the formula for an upper fence?
Q3 plus 1.5 times IQR.
Yeah, so it's pretty closely related to that. So there we go. Times IQR. The only thing we change is Q1 and Q3 and change the minus to a plus. Richard's asking, why are we using 1.5? So basically what it's doing is it's taking your IQR and it's adding 50%. Okay. So when you multiply by 1.5, that's the same as taking 100% plus 50% and adding those up. So the IQR is going to tell you how spread out your data is. So, but it's going to tell you how spread out the middle section of your data is. And the middle section of your data is usually a little more clustered. Okay. So you don't want to just take your IQR and add that to your Q1, because if you do that, you're going to have it's going to basically say you have a ton of outliers, and that's not really the case. Okay. That said, this lower fence and upper fence to figure out if you have outliers or not, it's kind of a rule of thumb, okay? Meaning like you don't necessarily have to follow it. When you're looking at your data, you can base whether it's an outlier or not on some other things. Later in this section, we'll talk about data, how to tell if data is unusual or not. And unusual and outlier are kind of interchangeable, but they mean different things. Outlier, we depend on looking at these fences. Unusual, we depend on looking at z-scores, but they mean the same thing. It means you have a data item that is way outside of your normal range. Okay. Anyway, so good question. All right, next, let's go to the next page, page 241. Sorry, 341, page 341. I mentioned before that there's a nice table on page 96 that you look at about whether data is skewed left or right. All right. All right, next, so we're still talking about energy usage. India had a per capita energy usage of 1.36. What's their z-score? So z-score is a formula on page 253 at the bottom here. And there's 3 formulas for it, but they're all the same formula, okay? You don't need all of them. You really just need one, okay? So it's the value minus the mean divided by standard deviation. And we put parentheses around the top because when you type this into your calculator or into Desmos, you're going to need to make sure that you put those parentheses there. Now, the next formula here is saying z is equal to x minus mu over sigma. Well, mu is the population mean. So it's the same thing. You take your value that you have, you subtract the mean, and then you divide by sigma. Sigma is the population standard deviation. So again, it's the same thing. It's just value minus mean over standard deviation, okay? The last formula for z-score is x minus x bar over s. Well, x bar is the variable for a sample mean, okay? And s is the variable for a sample standard deviation. So it's still the same thing. You take the number they give you, you subtract the mean, and you divide by the standard deviation, okay? Well, how do I know whether I have mu or s or sigma or x bar? So you're only ever going to need one of these formulas because if you have the mu, if you have the population mean, you don't need x bar, okay? You're never going to have both. You're never going to have both mu and x bar. The whole purpose of taking a sample, the reason we calculate an x bar is because it's impossible to calculate mu in some cases. Okay. For example, if I wanted to find the average height of all the people in the US, I can't go measure every single person. That's impossible. Okay. So I would need to take a sample. If I wanted to know if who's going to win the presidential election, I can't go ask every single voter. So I do a poll, which is a sample of the voters, and I can, ask maybe 1,000 people or 10,000 people, or maybe 100, depending on how big I need my sample to be. That's easier to do than trying to talk to millions of people. Okay. Anyway, so I know I'm spending a lot of time talking about z-score, but it's something that people often struggle with. So the z-score is basically measuring how many standard deviations you are away, how many standard deviations you are from the mean, from the middle. Okay. Okay. Anyway, we'll talk more about z-score. It's an important concept. Let's move on to question number 3. The birth rate of babies in the US is normally distributed with a mean 7.48, standard deviation 1.23. Okay, so construct this normal distribution. So right here in the middle, okay, this is the mean. So they said the mean was 7.48. All right. And by the way, this is all on page 253 right here. We've got uh, the percents. Here's where my mean is. That's what mu represents. And then I add and subtract standard deviation several times. Okay. So page 253. Okay. So if I add one standard deviation is 1.23. So this plus this adds up to 8.71. I can do that in my head. And if I subtract one standard deviation, that puts me here. And that's going to be 6.25. Okay. If you can't do that in your head, that's fine. Okay. You just go to Desmos, right? And you do 7.48 minus 1.23. There you go. Okay. No big deal. No one's ever going to be looking over your shoulder in this class saying, wait, you can't do that in your head? Okay. Use the calculator. Use Desmos as much as you need to. Okay. All right. So, sorry. The reason why we use standard deviation is because it lets us use the normal curve here, and we can estimate how much of our data is going to fall in certain ranges. %34% plus 34% is 68%. 68% of babies are going to land in this range, 6.25 pounds up to 8.71. Okay, right here. 68% of the data will lie within one standard deviation of the mean. Okay, so this was subtracting one standard deviation and adding one. And these, by the way, that's the z-score. The z-score is -1. This z-score is a +1. My z-score here is 0. The z-score of the mean is always 0 because the z-score is measuring how far away you are from the mean. So if you have a baby that's exactly 7.48, it's right on the mean, then your z-score there is 0. Okay. Now, if I go one more standard deviation out, so if I add 1.23 again, that's going to put me at 9.94, and that's going to put me 2 standard deviations away. If I subtract 1.23 again, I'll get 5.02, and that puts me at -2 standard deviations. So these numbers are 13.5 and 13.5. Okay. And I got that from here. So approximately 95% of my data will lie within 2 standard deviations of the mean. So from here to here is 95% of my data. 95% of babies are going to be between 5 pounds and 9.94 pounds. Okay. It's going to be very rare that you have a baby that's less than 5 pounds. That's your preemies. And then it's going to be very rare that you have a baby that's more than 9.94. It's rare to have a 10-pound baby. I mean, I was a 10-pound baby, but it doesn't happen that often. Okay. It happens 5% of the time. Okay. So we consider that unusual. Okay. Down here, the word unusual in this class, unusual means that the probability of the event is less than 5%. Okay. That's if we're looking at probabilities. Okay. Um, If we were looking at z-scores, it's not 5% then. In that case, unusual means is more than 2 standard deviations from the mean. No, that's not quite grammatically correct, but basically if your z-score is bigger than 2 or less than -2, we consider that unusual. Okay. And all that information is right here on page 253. Okay. If you're looking at z-scores, you check if your numbers are beyond 2 standard deviations. If you're looking at probabilities or percents or proportions, all of that means you're looking at the same thing. You're looking at decimals. In that case, we're looking at if the value is less than 5%. Okay. So every z value, this x-axis right here is actually a z-axis. Okay. And every z value corresponds to a probability. You can add these probabilities up. So depending on whether you're looking at a z-score or whether you're looking at percentages, you can tell if it's an unusual or not. Okay. Okay. Anyway, that all said, let's look at one more page and then we'll actually go back through and we'll answer all these questions. This last page, page 242, sorry, 342. Box plots. We've looked at box plots before. So which sport had the highest average? Usually when we mean average, we talk about mean, but box plots don't show the mean, so we'll just have to use median. That's fine. Which sport had the highest IQR? IQR is the size of the box, okay? The shape of the distribution, you'll find that on page 96, okay? I think most of this you guys can figure out on your own, so yeah. Okay, so I'm gonna stop the recording. We'll go back through the worksheet and fill everything else in, and we'll be good, okay?